So today is March 29th. Before we dive into continue with the lesson, I want to just quickly go over how to do the construction one more time, Achilles. So let me go over to the pink paper, the inside of the pink paper. So all the way in the back, we did circles. Turn it over so you're like at the other side of the pink paper. Okay, Evan, stop. Pay attention. So we're at the pink paper. We're just going to use this to kind of help us remind ourselves how to use it before we go back into the lesson. So Jose, I need to see you on the pink paper. Edwin, I need to see you on the pink paper. Anthony, I need to see you on the pink paper. All right, I need you to draw me on the pink paper. We're going to practice drawing a 6, 8, 10 centimeter triangle. Now, for those of you who are absent, pay close attention. The way we start drawing this is we start with the longest side. So 10. You are going to draw me a 10 centimeter line. Now, this is a ruler. The top numbers are centimeters, the bottom numbers are inches. So I'm going to draw a 10 centimeter line just by using the ruler. And I'm going to draw it kind of towards the middle. So draw me a line that's exactly 10 centimeters. There it is. So this line is 10 centimeters. I just used it as a ruler, a simple old school ruler of 10 centimeters. After you do that, what's my next step, guys?
We draw dots on each side.
Draw dots on each side. So I'm going to draw a dot on this side and a dot on this side. Now, we take this tool that we're not playing with, and we're going to set it to either 6 or 8 centimeters. It doesn't matter which one you choose. Let's do 6. So I turn it to the left to loosen it. And then I point one of the triangles to 6. Doesn't matter which one. So here is 6 centimeters. I'm pointing the triangle to 6 centimeters. I tighten the wheel. Now don't tighten it like it's going to be there forever. Just enough. Just enough. If you tighten it too much, you break it. So just enough. If I tap it, it doesn't move. If I feel underneath the magnifying glass, there's a bump on the magnifying glass. So Evan, Angel, feel underneath this round circle over here. Do you feel the bump underneath? That bump needs to go on top of your dot. That bump needs to go on top of this dot. So I'm going to put it on top of the dot. Hold it down with my non-dominant index finger. The non-dominant is the one you don't use to write with. And then what we're going to do is we're going to do a semicircle. Just a semicircle. You draw it out, just like so. Jesus, are you done? Yeah. Okay. Memorize the score. I'll ask you over here. Put the Chromebook away. Close it up. Sure. Yeah. Okay. So this is 6 centimeters. Okay. So I did the 10. I did the 6. Now I'm going to do the 8. So I move my triangle over to the 8. Slide it over to the 8. Close it up so it doesn't move. Now, I use one dot, right? Now I got to use the other dot. So I go to the other side, hold it down, and basically I want to know where these two arcs cross. If I do this is pointless over here. I don't need to go over here. That's just wasting my lead and my time. I need to focus on where they're crossing. Okay, they're crossing right here. This is where I should focus. Your second arc should be smaller than your first one. Your first one's usually big because you have no idea where that second arc is coming. Now I know, okay, it's somewhere over here. This is what I draw. This is all worthless. No need. Don't waste your time. Then the next thing I do is I draw a dot on the top of this where they cross. That's where I add my dot. I had someone last period or yesterday. They put a dot here. I'm like, why'd you put it? Well, that's where I ended my circle. I'm like, well, that's where you ended it, but that's just random place. You want to put your third dot where your two semicircles meet. Now we connect using our ruler, make a straight line, connect them, and this will create your triangle. You can go back and erase your arcs, those are just construction lines. They're not permanent lines. They just helped us, but they're not part of the triangle. When I go back and I measure, this measures exactly 6 centimeters. This exactly measures 8 centimeters. So this compass allows us to construct triangles. Pretty cool. Starts off by drawing circles, but in reality, we can use it to draw triangles. All right. Are we okay? Little recap, reminder. Some of you remember from yesterday, but it's always good just to remind ourselves. All right. So yesterday, everybody finished page 2, right? Okay. So Angel and Evan and Jesus, I want you to start on page 2. Everybody else, we're started on page 7. Page 7. Construct 7 and 8, please. Give you guys a couple minutes to do 7 and 8 before we move on. So on number 7, when you draw it out, you realize that the 2 arcs don't meet. And you might switch the numbers, try it again, try something different. Did I make a mistake? Let me do it again. Let me start with the 4, not the 2. But when we read down here, explain why triangle number 7 is impossible to construct. There's a reason why a triangle does not exist with the measurements 2, 4, and 7. Not all measurements create a triangle. Not all measurements create a triangle. Okay. Construct an isosceles triangle with a base of 3 centimeters and sides of 5 centimeters. What is isosceles? Anybody? Yes?
2 sides are equal.
Yes. Yay. 2 sides are equal. I should show you that. So when you read isosceles, that means 2 sides are equal. That's an equal sign right there.
And scalene means none of them are equal?
Correct. So, 2 sides are equal. Now you need your English skills. Yes, I know this is math. Read the sentence again. If 2 sides are equal, then one of those numbers have to repeat. So use your English skills to tell me which side repeats, which measurement repeats.
5.
How do you know?
It's probably 3.
And sides.
It's 3. Sides.
That's why I said use your English skills, because if it says sides, what does that mean?
More than 1.
More than 1. And here it says base of 3. Base is just 1, right? It's not bases. So that's why when the teacher's like, you need your English skills, you got to use your English skills. You can't just assume things. You got to take it. You got to take it slowly. All right, so now draw number 8. Knowing that the 5 is going to repeat. Go. So I will start with the longest side. So 5 aligned. 5. Okay, now set it to 3 or 4. Well, you already have 4, right? Sit on the dot. Draw. Okay. Switch it over to, yeah, it hurts your leg. For everybody. Hurts your leg. Alright. The 3. So, did you create an isosceles triangle with the base? Oh, a base of 3. Oh, they wanted 3 to be your base. And then 5. 5. Yeah. And then you have to create triangles, kiddo. It has to look like triangles at the end. So where they cross, that's where we put your extra dot, Jesus. And then you connect it to make it a triangle. All right, this is called an isosceles triangle. This is 5 centimeters. This is 5 centimeters. All right, are we okay with that? Isosceles triangles have 2 equal sides. Now the bottom. Describe triangle 4. Well, I got to go back to triangle 4.
Not 3.
So here is triangle 4, 3, 4, 5. What can we say about triangle 4? Describe triangle 4. Describe it based on the sides. What can we say about triangle 4? That would be the angles. So I'm asking you to do the sides, because you can't determine angles without a protractor. So what can you describe triangle 4 as? How many sides are equal?
0.
So write that down.
So do you write scaling?
Not yet. Okay, what about number 5? How many? 2 sides are equal? Number 6. How can you describe number 6 based on the sides? All of them are equal.
Equilateral.
Describe triangle number 7.
A fail.
Trick question, right? It is not a triangle. Explain why triangle number 7 is impossible to construct.
Its 2 sides are not bigger than space.
What do you mean? What do you mean, Andre? Sad. It's like, they don't cross it. It's like they have T-Rex hands.
They don't have to be bigger than the base. Look at triangle number 4.
Yes.
Do the sides have to be larger than the base in order to create a triangle? Doesn't matter if it's larger than the
Well, at this point, based on what you're telling me, Andre, 5 and 3 are smaller than 7.
5
Three-
and 3?
Right here. This is
That's
triangle.
4 and 3.
This is triangle number 3.
Oh, triangle number 3? Yeah, 5 and 3 is larger than 7.
How is 5 and 3 larger than a 7?
5 and 3 is 8.
So what are you doing with those two numbers?
It's larger than 7, so to create
So you're missing a verb in your description. That's why I kept asking, like, what do you mean? What do you mean? Because you have to be able to explain your reasoning and explain your math. But you're missing a verb in your explanation. You're not wrong, but you are wrong because you can't explain it. We're all going to learn it, but you have to be able to explain it with the correct terminology or even basic language. But you got to make sure you use the correct verbs. So I understand what you're saying, but I need you to tell me. Yeah. All right. So, Andre, when you figure out that verb, let me know. You're on the right track, but I need you to be able to explain yourself, because that's also a good skill to have as a student, to be able to explain yourself. Okay. What do I want to do? Can we skip over to page 5? I'm not ready for page 4 yet. I'm ready for page 5. Okay, so define scalene triangle. So some of you have been shouting it out. So this is officially the lesson where I teach you how to name triangles. So from this day forward, you're going to be a master at naming triangles, okay?
Why can't I just name them Bob?
No. Because Miss Scalene figured this one out, so she named him after herself. Yeah. Define a scalene triangle. A scalene triangle is what? What do we know? Who knows it?
Triangle that has no equal sides.
Correct. So a scalene triangle has no equal sides. Look at the example over here that are scalene triangles. Do you see how all of these, none of the numbers match? We're on page 5. We're on page 5. Not scalene triangles. Okay, sometimes you'll see these little like hash marks here.
These are equal to each other.
Yeah. So this one has 2 marks. This one has 2 tallies or hash. No, tallies. These 2 will be equal to each other. This has 1, 1, 1. So if they all have 1, 1, 1, that means all those match. So sometimes they won't write numbers, but they'll do these little tiny marks. That signifies that they're equal to each other.
Congruent.
Okay. Define isosceles. So we have scalene. Now we're talking about isosceles triangles. What are isosceles triangles?
Isosceles triangles have 2 sides that are equal to each other.
Yep, isosceles triangles have 2 equal sides. Cross this one out. This one's a mistake. Actually, not cross it out. What do we call this one?
Equilateral.
Yeah, so they made a mistake here. Let's circle it. And this one is not on your chart, so I'm going to put it down here. What do we call this one?
Equilateral.
Equilateral triangle. Equilateral triangle have 3 equal sides. Okay. Sorry. So this one is in the wrong place. And unfortunately, they forgot like number 6, define equilateral triangle. So we're going to add it at the bottom. An equilateral triangle have 3 equal sides. So this would be an example of an equilateral triangle. It's not an isosceles triangle. Someone's bad. Not mine. Someone. So this is an equilateral triangle. So circle it and define it down here. Equilateral triangle. All right. Are we okay? So far, so good? So this is how you name triangles based on the sides, Angel. Can you go back and name triangle 3, 4, 5, 6, and 8? Well, we already named 8. So can you name triangles 3, 4, 5, 6 based on the sides? So based on the sides on page, is it page 3? No, page 2. Page 2. So I'm going to turn to page 2. I want you to use the words scalene, isosceles, and equilateral, right? Yep, equilateral to name the triangles. So scalene, isosceles, equilateral to name the 4 triangles based on the sides. We're not talking about angles yet. Scalene, isosceles, equilateral. So name these 4 triangles. Pick a name. On page 2. Go. On page 2. Scalene, isosceles, equilateral. On page 2. What do you name? What do you name number 3? What do you name number 4? What do you name number 5? What do you name number 6? Okay, what do we name number 3?
A scalene triangle.
Yep, so please write down scalene. What about number 4? Scalene. Number 5? Isosceles. Number 6?
Equilateral.
Equilateral. There will be a spelling test on Friday.
What?
Can you imagine? Quick, how do you spell isosceles? Ah! Quick, how do you spell scalene? What?
Scalene would probably be fine, but like,
Isosceles.
Hey, it's like Jaylene, scalene. That's how you spell Jaylene, not with a Y. Very similar to scalene. So get rid of the SC and put a J.
Oh, G-A.
All right, okay. So we got to practice our ABCs. I've been known to have trouble with my ABCs too. In this class too, right? Andre, do not play with that.
Okay, J-A-L-E-N-E.
All right, we have time. Let's do it. Let's do page 4. Now I'm ready to talk about the angles. I wasn't ready before. Now I am. Okay, so we're on page 4. We'll do more construction probably on Wednesday. Page 4. Now we're going to name them based on angles. So triangles have, like I like to say that triangles have a first name and a last name. Just like you guys. First name and you have a last name. It doesn't matter which one's first name and last name. We can say the sides are the first name and the last name is acute, right, or obtuse. Okay, so a right triangle. Here are examples of a right triangle. Here are not examples. So what makes a triangle a right triangle?
It has to have a 90-degree angle.
How many 90-degree angles?
Because if it has 2, it wouldn't be correct.
Yeah, it wouldn't be a triangle. A right triangle has one 90-degree angle. One right angle, one 90-degree angle. Only one. Because technically you can't have more than one. You wouldn't be building a triangle.
Mr. Molly,
Yes.
I forgot what I was going to say.
Okay. Acute triangle. What makes a triangle an acute triangle? What is less than 90 degrees?
Angle smaller than 90 degrees.
Okay, but what makes a triangle an acute triangle?
Under 90? All 3 angles?
All 3 angles. Are what? Yep. So the key to acute is all of them. So an acute triangle has 3 acute angles. Okay? All acute angles. So all are less than 90 degrees. All angles, I should write the word angles here. So acute triangle has 3 acute angles. But what if you're sitting there going, what's an acute angle? So all angles are less than 90 degrees. So the key is that all 3 angles, not 1, not 2, all 3 of them. I know some of you are like, oh, it's not less than 90, but I needed more explanation. You need to elaborate.
All of them less than 90 degrees.
Yep. All right. Number 3. Define what an obtuse triangle is. Yes?
All angles are more than 90 one angle larger than 90 degrees. If it had 2, then it wouldn't make sense.
Yeah.
2 90 degrees already. Okay, we get it.
So, define obtuse triangle. An obtuse triangle has one angle that's more than 90 degrees. An obtuse triangle has one, Nicole, angle that is, who is it? Achilles? Has one angle that is more than 90 degrees. Just one. Not two, not three, just one. Yes.
Do you know what makes circles and circles and squares similar?
360.
Yeah.
Stop. Put that down.
They are mathematically the same.
An obtuse triangle has one angle that is more than 90 degrees. Now, let's look at number 8. Triangle 8, page 3. Triangle 8, page 3. We know it's isosceles, right? Because it tells us there. It's isosceles. What would be the last name? How would you name it based on the angles?
Acute.
So this angle right here, you can even cover up the triangle. Does that look like more than 90 or less than 90? Less. What about this angle? Less. What about that angle? So all three are less than 90. So the first name would be isosceles and the last name would be acute.
Acute isosceles. Or isosceles acute?
It doesn't matter.
Isosceles is bigger, so it should be in
But acute starts with an A and I figure we do it alphabetical order. Doesn't matter. Okay. Number 6. What do you call number 6? Look at it. Stop. What do you call number 6? Equilateral what?
Acute equilateral.
Do you guys want to know a little secret?
What?
All equilaterals are acute. All of them. Okay? There is no way around an equilateral not being acute. Yeah, but I mean, it's a gift. It's a gift. Yes.
Suppose a triangle bigger than another triangle can be the same in angles but cannot be the same in length, right?
Isn't this equal in length? 5, 5, and 5?
A big triangle and a small triangle can have the same angle but cannot have the same length.
Right, because you just called one big and one small. Isosceles, this one. What do you call, what's the last name? Isosceles what? Acute?
Acute isosceles.
Okay, we cannot do number 4 because I'm pretty sure you're going to get it wrong without a protractor. I'm doing the ones that are super obvious. Number 3. Can you name number 3?
Obtuse scalene.
So this angle right here on number 3, this one's acute, right? You see it's so small? This one is also acute, right? So you're basically what you're doing is you're imagining an L, right? And every time you look at an angle, you go, okay, is it smaller than your L? That's acute. Or is it wider than your L? That's obtuse. So always remember when you're going in here and you're looking at these, is this bigger than an L? Nope. Is this one bigger than an L? Nope. And sometimes it's easier for your kids to visualize it when they cover up the triangle and then just look at an angle. This one, and it's okay to move your packet. I know. This angle right here. Right here. If I cover this up, here we go. I'm going to erase this to... Think of your L. Is it wider than an L or smaller than your L? Right here. It's wider.
Therefore, it's an obtuse.
So this angle right here is opening wider than an L. So right here, this one is obtuse. How many obtuse angles do I need? Just one. So this whole triangle is called scalene obtuse. Because that one angle is obtuse, and so it makes it everything obtuse.
Scalene obtuse.
Questions?
Wait, number 4 is it right?
Mm-hmm. All right.
How do we know if it's not 89 degrees or 91 degrees?
You need a protractor.
And these triangles are exactly the properties.
Correct. All right. I think this is a great spot to end for today. We'll pick it up tomorrow. Let's pass in the compass. I'll pass out your homework.